Welcome structural engineers. Bismillah ar-Rahman ar-Rahim. Wassalatu ala Rasulillah wa ala alihi wa sahbihi wa man walah. My name is Modar Abdul Rhman Hajyounes, programmer of STEP program 2018. In this video we will compare between STEP program 2018 and ETABS program by example of design of shear walls, and we will see the effect of buckling in the design of shear wall. In the first stage we will go to ETABS program. We already make the tower with 25 floors, and the height of the floor at ground floor is 6 meter, and in the typical floors in 3.6 meter. And we already added the dead load and live load and static seismic forces and the response spectrum seismic forces and wind load also. And we design the shear walls, and we will compare in this example for this shear wall P7 in the story 1. The height of ground floor is 6 meter. Now we will from table, from design forces, from this we will take the combination by right click, copy. After that go to step, go to shear wall, clear. We already made this shear wall. Now we will paste from ETABS, remove the first line. We will go back to ETABS, and by right click we will check the design of this shear wall. The dimension is 300, 8000, FC prime 40, FY 460, FYS for shear reinforcement 420, and modulus of elasticity in this value. And we will go to here to check with this reinforcement 32, and here also 32, and here the space 200, and the clear cover is 330, and here check. Now okay, we will go to step. This also 300, 8000. This DCX from the edge of concrete to center of reinforcement equal clear cover plus half of the diameter, 30 plus 16. The height of the shear wall 6000 millimeter as per the picture here, LX and LY, and the conditions parameter KX and KY 1 meter. This is will consider it when we check the buckling. Now we will not consider the buckling in the design. FC prime 40, FY, FYS, and we will calculate the modulus of elasticity from this formula. Now we'll go to put the reinforcement, this 32 also as per ETABS, and num5, num y here about 37, here one and here one, and this 37 about 39 coming, and this is the number of this 37 coming from the length divided by the space 200, coming about 37 here, with this one and this one coming 39. Now we will go to check the results, and we will go back to ETABS. Now we will see here the checking ratio at the top is 1.282, and at the bottom is 1.731. Now from this combination 35, we'll go to step. We will check the results. You see here 1.68, 1.6 from which combination? Same combination. We'll go to combination 35, this one 35.7. we will which forces? This force, it's match with 35-8, this one. The checking ratio at top 1.244, in ETABS 1.282, is very close. Also at the bottom 1.731 from these forces, which at the bottom this forces, the checking ratio coming 1.68. It's very close to 1.431. For more accurate results, you can increase these numbers, but this will take more time. Now we will confirm the results between ETABS and STEP program 2018. It's very close. Now we will consider the buckling in the design, and we will consider this option to calculate the inertia of the section. This as per ETABS. ETABS only use this one. For more option in the STEP program, you can use the reinforcement. In this example, we will use only this one. Now we will go to check and draw. Check, click again if the 3D interaction diagram not shown. You can see now the checking ratio before 1.68, now 12.369, and there is warning message is NU, the applied load is more than the buckling critical load 0.75 BC from this combination. طبعا the program check all combinations, but this is now the first combination. See the program and show this warning message from this combination. This at top and at bottom, and you can see here the buckling. Now you can go to here to check parameter and increase the dimension, increase the FC prime, increase FY, increase the reinforcement if you can use this one, and also you can here add boundary element, and you can put a steel plate inside. You can make any option to make this wall safe. The ETABS model, ETABS program will show this shear wall as safe, but this is unsafe on the buckling. This program, STEP program, help you to consider the buckling and to solve this problem by STEP program. After you check in STEP program, go to ETABS and modify the dimension and reinforcement as the result of STEP. When you have building with 50 floors, it's logic to use this program to help you to redesign some walls on the buckling. Don't make it more trials by ETABS program, this take too much time. Thank you, structure engineer, and we will meet you also in the next video inshallah. Wassalamu alaikum wa rahmatullahi ta'ala wa barakatuh.